All right, so welcome to a little video where I'm just going to be talking about the attraction we did for our home haunt for 2023. So I just want to firstly give a little bit of a brief history of how this came to be. So essentially, last year we made a dark ride, right? You know, you've probably seen some other people do some dark rides. They're always super cool. But yeah, so we made a dark ride. It was pretty awesome. But you know, in order to make it even like a little bit cooler, we did a little bit of an elevator simulator going down into the dark ride, sort of as like a pre-show. But yeah, like it wasn't super crazy of an elevator simulator. Obviously, I had a lot more ideas on how to improve it, but all it really consisted of was some addressable LEDs to look like lights passing you by, and some a vibration motor to shake the floor, and like a little display that tells you your depth. And that was pretty much it. Obviously, there's audio, but that was pretty much it in terms of the elevator simulator. But people found it super cool. And I'm like, you know, I know I can do way better than that for an elevator simulator. So this time, this is that. This is the version 2.0. This is like the next generation. It's pretty next level, honestly. So yeah, and it didn't even have doors. It just had two curtains. Last year's one, so it had a curtain that you would open like on the entrance, and then you close it. You start the elevator simulator, and then you manually open the second curtain. So you could very easily tell that it's just two different things. But this one is a little bit different. As you can see, you enter the elevator, all right, and inside of here, you got a bunch of cool stuff, but you'll notice only one door. So that is what makes this thing so special. And honestly, I think this is the first that this has ever been done homemade. I have seen it done, you know, commercially and like in professional attractions, but I've never seen this done homemade, which is this entire room rotates. This entire room is a turntable, the 5 foot diameter turntable. This inside is like 3 by 3 foot, and it can support obviously hundreds and hundreds of pounds. And yeah, so this entire room rotates. This is the drive tire here. It is spring loaded to contact this 20 gauge sheet metal circumference, supported at various increments. And this is all thanks to AutoCAD. I've never used AutoCAD before, but I mean, I'm in school for electrical engineering and they did teach us it. So it came in handy. It definitely came in handy, like being able to just draw a circle in AutoCAD and now figure out all the measurements I need to make these like supporting pieces all to scale is really, really awesome. But yeah, so this is a drive tire, and it's just a wheelchair motor from last year's dark ride. I had two of them, so this is just one of them. And yeah, it's definitely pretty powerful little motor, 250 watt or so, permanent magnet DC, and yeah, it's definitely pretty powerful. It has its own gearbox and drive wheel and everything. And then this is the controller for that motor. Also using a lot of last year's parts, like the batteries. You know, I bought, yeah, it's battery powered, and then there's an H bridge made out of relays, so that allows us to go forward or reverse. And then there is an Arduino, which does a few things. It outputs PWM signal to the PWM speed controller, which is this circuit board under the gray enclosure. And so that does that. So that's how we control the speed, is with PWM. And I also added this. This is very new. I just added this, which is a infrared sensor that looks at these reflectors on the wheel, and the Arduino will actually look at that data and be able to determine the speed of the wheel so it can self-adjust. So, because we're having issues before where if there's a lot of weight, it would go too slowly, and that would cause the main control system to fault, and also just cause a bunch of other issues. So basically, and sometimes they get stuck and everything. So basically, this system now should be able to actually in real time monitor the speed and be able to self-adjust the power going to the motor to keep it running at the speed that we want it to run at. So that's super, super cool. But yeah, so kind of back to here, that's sort of the drive system. That's what rotates the entire elevator simulator. But what about the actual effects, right? Like what makes this so special? What makes it feel like an elevator? So first of all, we have the automatic door. This is done with a pneumatic cylinder. So it's directly driving this door. And this is just, of course, a cabinet or closet door track. So it has its little wheels and stuff. This door is just made out of super thin OSB. And we attached this to a little guide over here to keep it sort of on track. And yeah, that's the door. In terms of pneumatics, this is the pneumatics for the whole elevator. We have, obviously the main thing is this door pneumatics, and that, you know, has its own flow control. The solenoid is here with the mufflers on the exhaust, and then this is a regulator just for the door. So you run the door at around 15 to 20 psi, and the actual pressure coming into this board is 60 psi, because we also have an air blast. So this air blast just goes into there. That's for the jump scare, just to make it that much more intense. So it's pretty hidden. It's just a little tube here, but that's the air blast. And yeah, most people don't notice that that's there, which is great. You will definitely notice it on the jump scare when it blasts 60 psi at you. So yeah, we have the 60 psi coming from the compressor for the air blast, and it gets brought down to 15 for the door, so that it doesn't move super quickly, and it's also much safer having less pressure so it doesn't like crush you or something. But it's pretty hard for it to even crush you, since we have this complicated control system, which also has this beam sensor right here. So this sends an invisible infrared laser beam across the door, off this reflector and back to the sensor. So as long as that beam is not broken, it knows that this doorway is actually clear. So if someone is walking in, you're definitely going to break that laser beam. If I'm walking in right now, I'm breaking that beam. So that is actually super important for safety, obviously. If the door is closing and that gets broken, it's just going to immediately reverse. It's also important because we want people to stay inside the elevator for the whole ride. You're not supposed to jump out and look at different show scenes. But, I mean, we make it even more obvious by just having this little chain. It's more of a suggestion just to make sure that you stay in. But obviously, this is the real enforcer. If you actually jump out when you're not supposed to, it will definitely stop the ride. But also for the door, there's another sensor, which is this. This is one of those contact sensors. You've probably seen them in like security systems or something like that. But basically, and then the corresponding magnet is here. It's basically just a reed switch. So it's a switch, and then that's a magnet. So when the door is closed, that magnet pulls the switch closed, and it will then let the control system know. So the control system would know if the door is closed or if it is open. So like I said, lots of different faults can occur. Like if it's in motion, the door opens for whatever reason, then of course it will instantly detect that and emergency stop. Yeah, so that's pretty cool. In terms of emergency stops, right, obviously super important. We have an e-stop on the main operator panel and an e-stop inside the elevator. These are connected in series, so and they're obviously both normally closed. So essentially, it's fail-safe. So if I press this button, it disconnects the circuit. If I press this button, it disconnects the circuit. And yeah, so basically so that means that if any of the wires for the whole e-stop circuit, if any of those wires get broken, it will instantly e-stop. That's why you wire it like that. That's kind of the main stuff in terms of safety. You have this sensor, and of course there is security cameras absolutely everywhere, so we can monitor everything. So yeah, that's the main thing when it comes to safety. But also there's a bunch more sensors for turntable positioning, which I want to quickly show you. So there are 4 of these sensors, which are inductive proximity sensors, and there's of course one in every corner of the ride. And this is the actual flag plate right here. So you'll see a piece of metal is under there, and that is what triggers the sensor, is that metal. So that allows the control system to know the actual position of the turntable. So it's pretty important, right? So it will automatically stop itself at the different show scenes, and it will also be able to keep track of where it is. So if anything happens, if there is an e-stop, it can automatically reset. It can automatically bring itself back to the station position when you reset. Whoa. Sorry about that. I just dropped my whole phone. But yeah, like basically when you reset the e-stop, it will know where it was, so it can automatically bring it back. It's obviously super important, and it also checks for any unusual activity on the sensors. If, you know, where it thinks it is doesn't match up with the sensor inputs, it will very much e-stop. There's lots of different faults for the ride. Over here you can see all the different fault codes and what they mean. So you can see like all of these, another page here. Yeah, you can see basically anything that is unusual, anything weird is in there, and it will automatically be detected. In terms of controllers, we got a Contralino Mini as the main PLC, and this is running about 1,500 lines that I wrote of C++ code. That definitely took a long time to write, but it's definitely very, very overcomplicated, but that's how I like to do things. You know, I like to focus a lot on safety, and I love it when control systems can automatically detect faults. It's just super, super cool to me. So yeah, definitely a big fan of that, how it will, you know, if something isn't working right, then it will automatically e-stop itself before, you know, you as an operator even have time to e-stop the ride manually. And then here we have the Flex 2 from Fright Ideas. This is the actual show controller. I've obviously been hesitating on purchasing something like that. It's my first year using a controller from Fright Ideas, but you know, because it's expensive. I'm not gonna lie, it's expensive. These are professional controllers that are used in haunted houses, escape rooms, and everything like that. So as a home haunt on a budget, it's kind of it's up there. But you know, obviously I'm gonna be using this for other attractions. It is just a really, really, really awesome controller. It probably saved me hours and hours and hours of programming, and allowed me to do a lot of stuff that I would never be able to do, like DMX. I mean, technically, yeah, you can use DMX with Arduino, but it's just a lot harder to program, and this just makes it so easy having the timeline and the audio. So this handles the audio, all the show lighting. There's DMX lighting everywhere, right? Like up there, there's a DMX light. There's a fog machine that does DMX, and you'll see some more DMX stuff as we go through the ride. But yeah, DMX is definitely a game changer for this ride. And of course, it has 8 solid state outputs. We're using almost all of them to control various things, which you will see again. So yeah, super awesome. It makes it programming this controller so easy and so amazing that, yeah, like I said, this wouldn't be possible with an Arduino to this level. But yeah, so then of course, you know, I'll just kind of briefly go over the panel. This is the operator panel. It is all like professional Allen Bradley buttons with a Hoffman enclosure. It is not cheap, but again, this is just, you know, I was a ride operator at my local theme park, Canada's Wonderland, so I definitely know I like authentic control systems. I like high quality buttons and stuff. But yeah, like this is, you know, all professional. This stuff, I got this all used on eBay, but even used, this panel probably cost me probably around $300 or $400. It's definitely definitely not cheap, but I think it's super cool. Like these are the real buttons that you will find on real attractions that you will see. Yeah, and then of course, and then this one is actually button from a place called Microswitch, owned by Honeywell. I don't know. And this is another Hoffman enclosure, Allen Bradley legend plate. You know, it's pretty cool. But yeah, I'm kind of a nerd in that way, but yeah, that's kind of it. But anyways, over here, this is actually a display. There's an actual display for the control system, which honestly makes life just so much easier, being able to like diagnose faults and stuff. Instead of just e-stopping, it will actually tell me what the fault is, and it will also just tell you like various states of the ride. So it'll say, hey, you know, it's at the station, it's doing this, it's at this show scene. It'll just tell you a brief overview of what's actually happening on the control system. And this is from Adafruit. It is a RGB backlit character LCD with a serial backpack. So basically, this is actually also being controlled from the Contralino, which, if you don't know, is basically an Arduino, but an Arduino Uno, but like the PLC version of it. So that's basically, you can see I just attached it to the raw pins over here. So that's just getting 5-volt power and a serial connection using the software serial library. But yeah, it's pretty awesome. So we can actually see what's going on. Let me see if I can power up the control system and you can actually see what it looks like here. There you go. You see the firmware version, and okay, so you can see the e-stop is flashing. And this is very common for all control systems. Anytime a button is flashing, it means you can press it. If it's solid, it means it's probably been pressed, and if it's not illuminated, it means you can't press it. So you can see right now the dispatch. I can't press the dispatch. I can't dispatch the ride. If I go, and the reason is actually this sensor is not activated. So I think I just got to reposition it. There we go. So now that sensor is activated. So now the control system knows it is at the station. So now you can see the dispatch is flashing, which means we can start the ride if we wanted to. All right, you can see station idle. If I dispatch, says it's running the spiel, but you'll actually see in a second here. So it automatically e-stopped, and the fault code is door close fail, which is very true. The door did not close, and that's being detected by that sensor. So it's automatically emergency stopped. We can reset it if we want to by holding down that button. It says the e-stop reset is in progress, and give it a second. There's obviously a safety delay here, and now, yeah, it's just back because it knows it's still at the station, so it doesn't have to do any reset procedure. But yeah, of course, you can manually e-stop like that. And you'll see also something that happens is on an e-stop, all of the DMX lights turn on at their brightest setting. So you can actually see what's going on. It will also play an emergency message on the on-ride audio, the speaker, and it'll even show something on the display, which I'll turn everything on. Why not? I'll just reset that first. So to turn on the rest of the ride, I have this remote control. These are all remote control outlets, so I just need to actually turn everything on. And now, pretty much the whole ride is on. You'll see stuff booting up here, like the display. Give it a second. You hear some ambient audio, and now we have the display running. And I'll show you how that runs in a sec. You'll also see we have all the security cameras. So these are all like pretty high definition security cameras. I like them. Brand new for this ride. And yeah, we have obviously the DMX lighting. This is the station lighting. Controls, you can see, are all lit up. But yeah, so that's what it is. You see the beam sensor, what I was talking about earlier. But yeah, we still don't have any air pressure, so we can't really run the ride. There's no air pressure, so it will just instantly fault because it isn't able to close the door or open the door or anything like that. These are some of the show scenes. Yep, DMX light, UV DMX light, and yeah, so you can see all this stuff here. This is the mushroom scene. We built a frame, have it on a table here. This is just all made out of foam, of course, and painted. Inside you can see the tube for the fog, and the fog machine is, of course, just under there. Let me see if you can maybe see it. There it is. So that's a DMX fog machine, and yeah, I mean, like I said, lots of DMX, super cool. I'm being watched right now. This is the mirror illusion. You can kind of see my reflection here, but basically, because it's meant to work when this light is on. So this is just a one-way mirror made out of some pretty thin plastic. We wanted to go cheap with this because if we were to buy a one-way mirror, it'd cost like $300 or $400. Yeah, $400 or $500 actually. So it was, we just went with a cheap version, which is one-way mirror film that we applied pretty horribly. But and then behind here is actually some proper mirrors that we got donated from a friend. So that's really awesome. Proper mirrors. Up here we have a dimmer switch, which is running the LED, the dimmable LED light in there to keep it nice and dim. That's that remote control outlet. So I can, obviously I'm never leaving any ride elements powered on, especially with my questionable wiring. But no, I mean, honestly, I did actually take a class. I know electrical codes, and I know how to properly wire up these devices. So yeah, I've took a class where we actually did residential electrical installations. So I'm relatively comfortable with 120 volts and doing things properly. But yeah, over there is just a smoke alarm because there's a lot of paper here. We're not taking any chances, right? So that actually wirelessly interconnects to the alarms in the house. So that's also pretty cool. Behind here, this is a little bit of a behind the scenes area that you'll never see. There's some tools and stuff, and you can see actually the frame for the mirror illusion. And that right there is a solid state relay. That is what switches on and off the mirror illusion light from the from the show controller. So that cable is coming from the show controller. That's pretty cool. So that's kind of, a little bit of info on that stuff. This is the final scare scene. I'm not going to go too much into it. I mean, I'll kind of tell you, we have this cool thing. This is coming from the show controller. This is a relay, and this is a remote shutter that plugs into the camera, so we can do a scare cam where it'll actually take a picture of you. Perfectly timed. It's a jump scare because that's done from the show controller. Back here, you can actually see, this is where the live actor would stay. First they'd be sitting here, right? Do this creepy thing. The lights go out, and then they would actually move to this little hidden area. Obviously, the elevator would be here. They would move to here, and they have their little button, right? So this button will start flashing when they are able to jump scare. And then they have flexibility, right? They can choose when they want to actually jump scare you, which I think is really cool, and it also allows for perfect timing. So as soon as they press that button, it's actually going to jump scare. It's going to run the jump scare on the show controller. So they smash that button, jump over here, scare you, and that's it. I mean, here you can see the back of the monitor, some wire connections running to sensors. I want to go up there and show you some cool stuff. But I'll start in the elevator. Entering the elevator, you see the actual monitor. It looks honestly super, super cool. I didn't expect it to look this awesome. But yeah, it looks really cool. The mesh adds so much. I can't even lie. It even adds a 3D effect, which you can't really see it too well on video, but in real life, it actually looks somewhat 3D. Yeah, this painting, okay, we have never done painting or scenic painting or anything like that. So we kind of just went all crazy. We just went to got a bunch of acrylic paints and just started going crazy with sponges and stuff. We think it turned out okay. It's just meant to look like a shitty paint job. So we got the perfect people for the job, right? But yeah, that's that. Up here, yeah, you see the in-ceiling speaker. Right now it's running ambient creaking noises. We have some custom posters that we did. We have this totally normal light bulb, not at all a few nano spotlights. These are 12 volt LED spotlights from, I think, Gantom, but I got it from Fright Props. And then this is just a bulb that I gutted, and it's just the 12 volt spotlights in there. And this is just a standard light base. It actually works. It's actually connected like that, which I think is pretty pretty funny. But instead of this being 120 volt, I mean, I can touch this all I want. This is 12 volt DC, and this is just not a normal bulb, as you can tell. Definitely have to be careful, make sure no one puts a normal light bulb in here. It would probably like screw up the output or something, but screw it back in, and there you go, it's doing its thing. So yeah, like I said, that's 12 volts coming directly off of the show controller. Output 7 there. You'll see it flicker here. Yeah. So that's just a dimmable output on the show controller. So it's doing some cool ambient flickering stuff. But yeah, we have full dimmable control of that. Really awesome. Up there you can see some of the wiring and stuff. We have air line coming down. We have, this is the back of the e-stop. This is some voltage conversion modules. I want to get up there because there's some cool stuff up there I want to show you. All right, I pulled out the ladder from the secret hiding place. We're gonna go up here so you can see some of the cool stuff up here. So up here we got this, which is a audio amplifier. So this is one of those little knob sound units. So it's pretty cool. It has 2 channels. One is going to the in-ceiling speaker, but the other one is running all the way down here. Where could that be going to? An audio channel? Let's take a peek underneath. Whoa, is that a bass shaker? Yeah, so, and then you can also see some of the wheels and stuff. Pretty cool. So that's a Dayton Audio BST-1, which is a bass shaker. It is essentially a subwoofer that mounts, and its goal is to shake things. It's not to shake the air like a normal subwoofer, it's to shake things. It's a transducer. So that is being driven off of the left channel, which means I am sending different audio signals to the left channel, which is the bass shaker, and right channel, which is the main audio from the speaker. So we are essentially, we're doing some shaking, okay? We are shaking the elevator, mainly the floor, but you even hear it and can kind of feel it in the walls and everything. So super, super cool. Basically, it's way better than a vibration motor. It feels a lot more realistic because we're able to send whatever bass frequencies we want. It is super cool. So that is the bass shaker that's being driven, like I said, off of this amplifier. The audio signal is coming directly from the show controller, so it's pretty awesome. Now over here in the center, this little gray box, this is interesting. This is a scent distribution. So inside of here is one of these things from Froggy's Fog. It's called scent distribution cup, and it is essentially just a cup of like some cotton swab, like saturated with some pretty strong scent. This one is a dirt scent for obvious reasons. This is a mine shaft. If I open this up, you can kind of see inside. I have another one of those voltage conversion modules, the scent cup, and a fan. That fan just blows the air from that hole, goes over the scent cup, and brings that air that is now scented with dirt into the elevator. So that is super cool because you don't smell it when you first come in, because at first you're in a garage as part of the story. But once you come in, you don't smell it, and then once you actually make it to the first mine shaft floor, which is this one, and you see the infinite mine, then it starts pumping in the scent directed because of a output on the show controller. So like I said, it starts pumping in the scent, the dirt scent, so it actually should be pretty cool and relatively realistic. But now I'm just going to move over so you can see how the video display is handled. Right up here, as you could have guessed, is MediaWiz Sprite, which is it's a very, very cool like video player that is super, super programmable and controllable. You can control it with serial, you can control it with push buttons, you can have it loop, you can have it autoplay, you can do a bunch of really cool stuff. If you're doing digital signage or any kind of video display for escape rooms and haunted houses, this is what it's meant for. Right, so I have a video SD card running with all the videos on it, HDMI output, power input, and this is a special little thing. This is also from Fright Ideas, and it is the Sprite to DMX interface. So this actually converts serial to DMX. So this is the DMX cable coming in from the DMX chain. This is the end of the chain. So basically we have the data wires in there, the shield connected there, and this is a DMX termination resistor that I made. It's just a 120 ohm resistor, and that is there to terminate the signal at the end, just part of the DMX protocol. And you can see that light is on, telling you that you have a good DMX signal. And this green light will come on anytime it receives a DMX command. So essentially, that means we have full control of this video player from the show controller. So the show controller will actually tell it, hey, play this video, and it will just play the video. So it's really, really cool that it's able to do that. Like if you just have like a standard trigger, you know, you can do some cool stuff with the trigger, but you know, obviously if you want real like crazy amounts of control, then you're gonna need a actual you're gonna need more precise control like serial or DMX. So I mean, you'll see actually if I e-stop the ride, it even has a message on the display.
May I have your attention, please? This
And an audio message.
Experienced an emergency stop.
And you can see all the lights came on. Like I'll turn off the main lights, and you'll see all of the lights have come on, so you can actually get around and see what's happening. You could evacuate. Even the mirror illusion light came on, so you could actually see a bit of the mirror illusion there. But yeah, there's all the cameras you can see. And I'll reset this, and they all flash. It's pretty cool. Tells you that it's gonna move shortly, but since it's right at the station, it's not gonna move. But yeah, pretty cool. So I'll turn the house lights back on. But that's kind of an example of that, right? So then basically we have precise control. If you had a trigger, you wouldn't be able to do that. But yeah, pretty cool stuff. And that is, honestly, that's kind of it for the most part. I mean, maybe I'll give some details how I built this platform. The platform was built, the turntable rather, was kind of a design I came up with. But yeah, so a little bit of detail on how the turntable was made. So it was all made for under $1,000. Basically, I already kind of explained how this circumference thing was made with AutoCAD and making all these different dimensions and stuff. But the actual turntable itself, in the center here, is supported with a 12-inch diameter Lazy Susan bearing. It says it has a load capacity of about 1,000 pounds, which seems to be pretty good. But in addition to that, to support the outer edges, we have a little wheel assembly that comes out like this. It goes this way, this way, this way, this way, and in the corners. So it has 8 wheels total. Each of those wheels are rigid caster wheels, and they are able to support about 100 pounds each. So, I mean, theoretically, we have 800 pounds of load capacity around the outside and 1,000 in the middle. I mean, we're never going to put anywhere near that amount of weight on this thing. I think the motor will stop. We'll have trouble driving it if we ever do something like that. And yeah, I'm not going to mess with that. But yeah, so that's kind of this whole elevator simulator. I think that's pretty much it for the most part. The air compressor is there, by the way, just for running all these things. But yeah, that's kind of it. I mean, don't really know what else to say. I mean, these are all paper walls, obviously, made with these little very, very non-sturdy frames that we made super quickly. But yeah, this is the elevator, man. Like, I think it's definitely a big step up from last year. I mean, there's no questions about that. But yeah, that's kind of where we're at. So thank you for watching. Yeah, definitely check out the POV if you haven't. I mean, I'm sure you probably have, but check out the POV. It will definitely explain. It'll show you the ride, and you know, there's a pretty interesting story behind it. So yeah, that's pretty much it. So thanks for watching, and I'll see you in the next video. Thanks. Bye.